Today we're going to take a look at two different types of free response questions that pop up a lot on the AP exam. The first are these problems where they give you the rate at which something is being added and the rate at which something is leaving or losing or being removed. So in this case, we've got fish that are entering a lake at a rate, so this is a rate modeled by that equation. And then we also have fish leaving the lake at this rate. So we're given a rate at which something's being added, a rate at which something's leaving, and we are also given that t is number of hours measured since midnight. So part A asks how many fish entered the lake over the 5-hour period starting at midnight until 5 a.m. So we are only concerned about the number of fish entering the lake, so we only want to work with E of t. Because we are given a rate of change and we want the number of fish, we want to integrate E of t dt starting at time 0 and ending at time 5. So I've already graphed both of our equations here. We only want E of t, so I'm going to turn y2 off. And we want to calculate the area under E of t. Starting at 0 and ending at time 5. It told us to round to the nearest whole number, which would be 153. Part B wants the average number of fish that leave the lake per hour. So fish per hour is a rate. So we want the average rate, and we are given a rate. So this is an average value problem. We're looking at the number that leave, so we want the average value of L of t on the interval from 0 to 5 is what we're looking for. To find an average value is 1 over b minus a times the integral from a to b of the function dt. So we want L of t instead of E of t. Turn E of t off and L of t on. Calculate the integral. From 0 to 5. And then divide that by 5 times 1/5. 6.059 fish per hour. Part C wants to know at what time t for time 0 to 8 is the greatest number of fish in the lake. So we want the total number of fish in the lake to be a maximum. So a maximum is going to occur when the rate of change is 0 or at the endpoints. So what we want is we want E of t minus L of t. That's going to be the overall rate of change. Rate entered minus rate leaving. We want that to be equal to 0. So going back to our y equals here, this is E of t is y1 and L of t is y2. So I'm going to go to y3, and I want to graph y1 minus y2. Alpha trace will pull up this screen here, and we can graph y1 minus y2 at E of t minus L of t. We want to know when is that 0, in between 0 and 8. So it looks like from 0 to 8, it's only equal to 0 once. we want to calculate that 0, somewhere in between 0 and 8. It happens at 6.204. There are a couple different ways that you could justify that this is the maximum. And it's not simply because this is a relative maximum. So the overall rate changes from positive to negative. But just because it's a relative maximum doesn't mean it's the absolute maximum. And it could look something like that, where you have this relative maximum, but it was higher over here at the endpoint. The most common way to justify is to list the number of fish added, or the change in fish at different times. So we don't know how many fish we started with. So let's say at time t, we have 0, 6.204, and our endpoint is 8. And then let's actually call this change in fish. So change in fish from 0, it doesn't change at all. The number of change in fish from 0 until 6.204 we can find by the integral of e of t minus L of t. So 135. And go from 0 all the way out to 8. Uh, 81. I probably should have rounded the 3 decimals there, but so this shows that the maximum occurs at time 6.204. Another way you could justify it is by stating that e of t minus L of t is only positive, so we are only gaining fish until time 6.204, and then we only lose fish until time 8. So if a function is only increasing and then only decreasing, the relative maximum right there has to be the absolute maximum as well. And the last part to this problem, part D, asks, is the rate of change in the number of fish in the lake increasing or decreasing? So we want to know, is the rate of change increasing or decreasing at a specific time? So rate of change increasing or decreasing, we want to know, does the rate of change, does the overall rate of change, which would be e prime of t minus L prime of t, we want to know, is that positive or negative at time 5? So by far the easiest way to find this, instead of finding the derivative by hand and then plugging in 5, we have graphed e of t minus L of t. So we are going to calculate the derivative of that at time 5. Negative 10.723. I would state that e prime of 5 minus L prime of 5 is less than 0. You do want to show what value it has. Therefore decreasing. So that's one very common type of problem, these rate added, rate removed type problems. The other one I want to take a look at is the position, velocity, acceleration type problems. Usually on these, this one here is a very typical problem in that they give you an equation for velocity, they tell you the particle's position at a certain time, and then they ask you some questions. This one is a calculator problem as well. So let's go ahead and graph that velocity there. So the first part of the question, part A, is asking for the particle's acceleration at time 3. So acceleration is the rate at which velocity is changing. It is the derivative of velocity. So we want the derivative of this function at time 3. So because it's calculator, we can just use the dy dx function on the calculator. At time 3, whoops. Negative 2.118. So as far as work here, I'd show that you found the derivative of velocity at time 3. What did I say it was? 2.118, negative 2.118. No units are given. It doesn't ask for units here. That's it. Not a lot of work to show there. Part B wants the position of the particle at time 3. So we're given a velocity to go to a position we want to integrate. If I integrate v of t dt starting at time 0 and ending at time 3, that will give us how much the position has changed from 0 to 3. And then we need to consider that it started at negative 5. So on the calculator, we can integrate from 0 to 3. So its change in position is 3.2397 plus negative 5. Negative 1.76, was that a 0? Part C asks us to evaluate the integral from 0 to 3.5 of v of t dt and to evaluate the integral from 0 to 3.5 of the absolute value of v of t dt, and then to interpret the meaning of each integral. So we've already graphed v of t, so it'd be easy to go from 0 to 3.5 here. So the integral from 0 to 3.5 of v of t dt is equal to 2.844, whereas the integral from 0 to 3.5 of the absolute value of v of t dt So going down to y2, we want to graph the absolute value. You go to math, scroll over to number, and then it's the first one. We want to graph the absolute value of y1. And we want to integrate that from 0 to 3.5. And this time we get 3.737. So the difference between these two, we actually just kind of talked about a minute ago what this means. This would be the change in the particle's position from time 0 to 3.5. Whereas this, because we're taking the absolute value, it doesn't matter if velocity is positive or negative. It's going to count all that as positive. So this is the total distance that the particle traveled starting at time 0 and ending at 3.5. Basically, if it starts here and it goes 10 centimeters that way and 2 centimeters back, if we did it like this, we would get 8, because this would count as positive 10, this would count as negative 2. So its position changed by 8 units. Whereas if we did this, I took the absolute value, it would count this as positive 10, and it would count this as positive 2, so we would get 12, which would be the total distance that this particle traveled. And last part D, says we've got another particle. Its position is given by t squared minus t. It wants to know at what time are the two particles moving with the same velocity. So this time we're given position, so we should probably get velocity of this second particle. And we can get that pretty easily, 2t minus 1. And we want the velocities to be the same. So we want 10 sine of 0.4 t squared over t squared minus t plus 3 to be equal to 2t minus 1. Probably the easiest way to do this, you could set the two equations equal to each other and try to calculate the intersection. Sometimes that's not the easiest thing to do, though. I think it's usually easier if we get the equation equal to 0. So subtract 2t and add 1. So I want to take y1, subtract 2x plus 1. And now we are looking for the zeros of this graph. I want to know when is that 0. It's kind of hard to tell if there's 1 or 2 of them there. I'm going to change my y min and y max to kind of zoom in just a little bit there. And looks like there is just 1 0 there. It's in between 1 and 2. So calculate the 0. It's in between 1 and 2. And there's our answer, around to 3 decimals. 1.571 is the time.